So guys, today we are going to discuss one of the important concept of ASP.NET Core Web API, that is the Redis cache. So Redis cache means it is one of the caching solution for the distributed caches. So first of all, we will discuss what is distributed caching. Then we'll see why we should use or why we should prefer distributed cache instead of a memory cache. And then we'll see how to implement distributed caching using the Redis cache. So that is what is today's agenda. Guys, remember, if someone asks you why we need to use caching means to improve the performance. So caching means to reduce the load on the database. So how it can improve the performance, how it can reduce the load on the database server. So for that to understand, right, please look at this image. Like for example, okay, I will come to this image later. Now let us first try to understand what is the issue with memory caching. So if you are implementing in-memory caching, what are the drawbacks? So in memory caching, what are the drawbacks? Drawback is they are limited to a single server or multiple server. Guys, tell me.
Single server.
Single server.
Single sir.
Single server. Single server means on which server your application is hosted. Whatever the data you are going to store, the data is going to be stored inside that server only. Is the data whatever you are storing on the cache is going to be shared between multiple server? Data is not shared. Why it is not shared? Because it is limited to the single server. That means if you want to enhance this functionality, means what? If you want to store the data and you want to reuse the data, or you can say you want to share the data, then in-memory caching is not the solution. So the next problem is if the server restart, then what will happen? Server restart means data is lost or not? Yes or no? So if your
Yes, sir.
server, whatever the data you are storing in the in-memory cache, I mean, it is going to store in the RAM only. So once you restart your machine or once you recycle the Apple, then whatever the data you are storing, the data is going to be lost. So means once the server restart, the data is going to be lost, right? Then what is the next problem? Next problem means if you store right huge amount of data, it means a huge amount of data means it can also huge amount of data means it can also reduce the right what you can say reduce the performance. So how it can reduce the performance? Let us try to observe, right? For example, your RAM is going to be some 8 GB or 16 GB, let us assume. And if you are storing some right out of 6 GB RAM, your cache data is going to be something around 3 GB or 4 GB. Then that means more memory is going to be utilized by cache. Then very less memory is there, right, which is going to do some kind of a other operation. Means if there is less memory available for performing some other operations, that means it can also impact your application performance. So these are some of the limitations of in-memory caching. Then what is the solution? The solution is distributed caching. The solution is distributed caching. The solution is distributed caching. Sir, what do you mean by distributed caching? So what do you mean by distributed caching? Distributed caching means storing the caching data in an external or you can say dedicated cache server. So distributed caching means storing the data, right? Storing the data in an external server. So it is not limited to your, right? That means wherever your application is hosted, we are not going to store the data inside that application server. Rather than we will create a separate server, dedicated server for the caching. From my application, whatever the data I want to store and I want to retrieve, I need to communicate with the external server. That external server is going to store the data. That means in case of a distributed caching, it is going to store the data in an external server. So as it is going to store the data in an external server, then what benefit we will get? So what benefit we will get? So what benefit we will get means data can be shared. data can be shared. Sir, how the data is going to be shared? Let assume you are having three applications. App one, I mean, I'm taking one, right, what I can say, load balancing environment. So in my case, right, I'm going to host my application in three different server. So let assume this is app one server. This is going to be app two server. This is going to be my app three server. So my three server are there. So when the request comes to this application one server, it fetch the data from DB and store it in the cache. Store it in the distributed cache. Store it in the distributed cache. Then when you request for the same data, right, let's see, the second request comes to application to server. So when you request for the same data, then the application server is not going to check whether the data is available within the memory. Rather than it is going to check whether this data is available in the cache in the external server. And in the external server, the data is already available. How? In the case of when the first request comes to application one server, application one fetches the data and store it in the distributed cache. And when the same request comes, and this time the request is in ready to handle. I mean, second time the request is handled by application to server. Then in this case, what will happen? Now, in this case, application 2 is also going to use the same distributed cache server, or you can say external cache server, and it is going to check whether the data is available. Yes, the data is already available, which is stored by the application 1 server, so it can retrieve the data. That means the data is going to be stored by application 1. The same data can be reused by application 2. So that means the data can be shared. So, when the app server restart means data is never going to be lost. App server restart means data is not lost. So what exactly it means? See, now my caching server is different, my application server is different. So if I'm restarting my application server, the data is not going to be lost from the cache. Why? Because that external server is different. And that external server and my application both are different. If I'm restarting my application server, then it doesn't have any impact on the cache server. And second, and the final thing, that performance is never going to be degraded. Why? Because the application server is different and the cache server is different. You can increase the memory size, RAM, right, processing power of your caching server, and he can handle very huge amount of data, and your performance is going to be better. Now, if you will ask you, right, if you ask me, sir, between this in-memory caching and distributed caching, which is going to give you better performance? Now this is not you are not asking me this question. Rather than I am asking this question to you guys. In between, so between this memory cache and between this distributed caching, which is going to give you better performance? And why?
The in-memory caching.
Distributed caching.
Right?
In-memory
Definitely
caching.
in-memory caching is going to give you
In-memory.
better performance. Why? Because in this case, the cache data is going to be available within the same server. So it is not going to communicate with an external server to get the data. Fetching the data from the one RAM and fetching the data from external server's RAM is going to be different. So in the case of a distributed caching, from my application server, I am communicating with the distributed server. That means one IO operation is performing. So that IO operation means some additional resources is going to be, right, what I can say, consumed. So that is what you will not face in case of memory caching. But again, if you are using memory caching, the limitation is going to be there. So it is limited to a single server. The data is never going to be shared. Once your server is going to be restarted, whatever the data you stored on the cache, they are going to be right lost. And if you are going to store a huge amount of data, then it can impact your application performance as a huge amount of memory from the RAM is going to be consumed for the caching. And these limitations we can overcome by using distributed caching. So, and again, this distributed caching, it's not it's going to be little bit, it is going to, if I'm comparing from the performance point of view, so definitely this is going to take more performance, right, less time, and this performance can be negligible here. So in the case of a distributed caching, that performance we can right, ignore, or you can say we can neglect. Why? Because the amount of advantages what we are getting by comparing with in-memory caching, so that little bit performance impact we can handle. Now you might have one question, sir, what is the difference between fetching the data from the database and fetching the data from the Redis cache or some external distributed caching? Sir, what is the difference? In this case, we are communicating with the database, getting the data. In that case, right, in case of a distributed caching, we are communicating to the external server and fetching the data. Then what is the difference between them? Guys, remember, so fetching the data from the RAM and fetching the data from the hard disks, if if you both going to compare this thing, if you are trying to access something from the RAM and something from your hard disks, then definitely whatever you are accessing or accessing, right, the retrieving from the RAID RAM is going to be better, right? I mean that performance is going to be better than fetching the same information from the hard disk. So if you are retrieving the data from the database, means you are retrieving the data from the hard disks. So whatever the database table, whatever you are creating, the data is not going to be stored on the RAM. They are going to be stored on the hard disks. And in case of a distributed caching like Redis cache, Memcache, Ncache, whatever we are going to use, so they are going to store the data in the RAM only. So that means even though both are going to be, even though in my case, database is external, my Redis cache or external distributed caching server is external. So both are external. Even both are external, accessing the data from the distributed caching or the external server going to give you 100% better performance than accessing the data from the database. Why? Because in that case, right, whenever I'm using in-memory caching or distributed caching, caching means the data is going to be stored in the RAM only. Database means the data is going to be stored on the hard disk only. So fetching something from the RAM definitely, right, 100% better than fetching from the database. Clear?
So I have one question, sir.
Yes, please.
So if the distributed cache is storing in the RAM, if you restart the server, then the data will be lost.
So in that case, what server you are restarting?
The cache server, distributed cache server.
Why you are restarting the cache server? What is the use for restarting?
Now suppose, sir, if you restart the cache server,
Output means, see, without any reason, right? If you will ask me, sir, if I ready stop my application, if I stop my server, then the application will not work. Yes, it will not work. So if you are restarting means you know the data is going to be lost,
mhm.
right? And in that case, right? So now you just now the question should be like this: at what scenario we can restart the what I can say, the distributed server. The question should not be like this: what will happen
Suppose, sir,
when we?
suppose,
The
sir,
question should be like, when we need to restart the ready cache server.
let's take Windows update happens, then it will restart the server. No?
See, guys, remember, if you are restarting means whatever the data, they are going to be lost, 100%. But do you think that window rate update, whatever you are talking, is this going to be happen automatically or for handling this thing, right? For this for handling this thing, right? You are going to have some
Dedicated team.
dedicated team. So if they
Probably
want to
there
do
will be a
some kind
backup.
of right, so infra team is going to be there. So if they are going to do something like this, then what we need to do? Definitely the data
Backup.
is going to be lost. So what is the solution? The solution is it preload the capture data. So once your server is restarted, so you need to write some kind of logic which is going to automatically load the data from the database and store it on the cache server.
Mhm.
Clear?
Yes, sir.
Right? Then the second question, right? That is another thing. But see, if you are going for the Windows class option or something else, right? Mostly nowadays we are not using that kind of functionality. We are mostly preferring to host our application on Redis cloud. That's fine. So my question is, when we need to restart the server? So basically, for example, you are storing data in the cache. Then let's assume that whatever the data you stored, right, in the cache, so there is a huge update happening in the database. I mean, most of the data, right, whatever you are storing, they are updated. So once a huge amount of changes are happening on the database, so you cannot return the data from the cache because the updated data is available on the database. So in situations like this, you need to restart the cache. Other option is that so without restarting the cache server, is there any better approach? Yes, better approach is available. What is that better approach? Okay, let me clear the cache from the Redis. So those functionality also we are going to provide. So basically, what we are going to discuss, we are going to discuss how to download the Redis server, how to integrate Redis server in our ASP.NET Core Web API application, how to store and retrieve the data from the cache with the expiration policy. Then also I'm going to show you how you can create endpoints or APIs you can say for managing the caches. So basically, if you want to see what all caches are stored, how you can retrieve. If you want to retrieve a particular cache information based on the key, how you can do this. So you can remove a single key, right, cache entry based on the key, and how you can remove all the cache entries from the cache server. So those functionality also we are going to discuss. Clear,
Yes, sir.
right?
Yeah,
Anyone having
excuse
any
me, sir.
question?
Yeah,
Yes.
so can you please give some real-time examples, like use cases where we should use in-memory caching and distributed caching?
See, see, you just tell me, right? This is my second session related to caching. Did you attend the first session?
No, I didn't.
So then, right, you will not understand this thing, right? So basically, whatever the static information, whatever the static data which is not going to be updated frequently in the database, those static informations are good candidate of caching. For example, country master, city master, state master, and category, different kind of role master. So these are right payment type. What I can say, the status master. So some kind of master data which are not going to be changed frequently. These are you can consider some kind of a static data in our database. So those data which are not changing frequently, you can consider for caching. Clear? So which data is good candidate for caching? Clear? So any kind of a master data which are not changing in your database. For example, country master. Is the country data is going to be changed frequently? No. State master, city master, some configuration data. For example, your application is going to be consumed by Android user, iOS user, web application user. For Android, that configuration settings is different. For iOS, the settings are going to be different. For web application, the settings are going to be different. So those configuration data, they are not going to be changed. For example, you are providing some kind of a panel where the user going to add product. So product must belongs to a particular category. Your category master is not going to be changed. For example, you are having the admin panel. So in the admin panel, you are going to create some different kind of a user. And whenever you are going to create the user, each user can be assigned with some kind of a specific role. That role master is not going to be changed. For example, your application is going to handle some kind of a payment information. Payment options your application is supported is cash on delivery, credit card, debit card, UPI, PayPal. So these are fixed amount of options. So these are going to be your master data. So whatever the payment status is going to be what I can say, pending, cancelled, processed, success, completed. So these are some master data. So these data are good candidate of caching. Clear?
Yes, yes.
Right. Now when to use in-memory caching and when to use a distributed caching. For example, you develop a single application. Means your application, whatever application you develop, that is going to be hosted on a single server. Right, observe my point. That application is going to be hosted on a single server, and the data what you are going to store on the cache is very fixed. So if the data is less, if your application is going to be hosted on a single server, and if there is no issue, if your data is lost when your application is restarted, if you have no problem, then you can consider using in-memory caching. Clear?
Yes.
Then when to use distributed caching? Let us try to understand that with one diagram. So this diagram right will give you right good clarity of distributed caching. For example, what I have done, I have developed one application. And as my application is going to handle, huge amount of traffic. For example, let assume, right, this is one interview question, guys, remember. So let assume I develop one application, right? I develop one application, and that application currently handle thousand of requests per minute, 1,000 requests per minute, right? And it is working fine. So it handle 1,000 requests per minute, and it's working fine. Now suddenly what happened? My website traffic is increased to 3,000 requests per minute, and my server is unable to handle this thing. And my server doesn't have that capacity to handle this amount of requests. Then what is your solution? This is one the real-time scenario question. Am I right?
Uh,
Yes or no?
we
I
can
think
host
this
the
question is being asked by someone in the Telegram group, if I'm not
yes,
wrong. Right. So what is the solution?
we can host the
Load
application in
balancer.
other.
Scaling, load balancing or scaling.
Horizontal scaling.
Right. So basically, horizontal scaling we need to implement. So basically, I cannot go ahead and immediately I can make the changes in my code so that the code is going to be optimized and right the performance right my application can handle 3,000 requests. That is not possible. Right? Yes, that is possible, but for a long what I can say longer period of time. A longer period means it will take more time. So you need to analyze your code. Where is the issue? How you can handle? Where you can implement? So this is right one of the solution. You can, if you are not using caching, right, then you need to think about how to implement caching, and all these things will come inside your application code. And that is not a immediate solution. Immediate solution means it is not possible that within 1 hour or one day you can fix everything and you can redeploy the application without testing and it can handle 3,000 of requests. That is not possible. Completely, it is impossible. Then what is the solution? The solution is to deploy my application into three different server. Currently, that application is deployed into one server. Instead of one server, what I need to do, I need to deploy my application into three different application servers. So app server 1, app server 1, app server 2, and app server 3. So these are my three different servers. So now what we need to do, so on top of this server, right, what I need to do, I need to implement something called a load balance, right? So the request now will not directly navigate to this application servers, rather than the request, whatever you send, right? Whatever the client send the request, right? That request will be handled by this load balancer. And this load balancer, by using some logic, right? Round robin, right? Or some kind of logic, right? Evenly it is going to decide right, that particular request is going to be handled by which server. Means once you send a request, that request will be either navigate to server 1, server 2, or server 3. That means if your application is receiving 3,000 requests, now the 3,000 request will not be redirected to your application server. This 3,000 server will be handled by this load balancer, and this load balancer will decide which request, right, which 1,000 request. I'm not right. So don't go with that exact number, but you can consider, right, 1,000 request will be right handled by this application server 1. 1,000 request will be handled by application server 2, and 1,000 request will be handled by application server 3. So if that is your question, you need to tell we have to make it horizontal scale. Horizontal scale means we need to implement multiple application server. We need to implement one load balancer, and that load balancer is evenly right navigate or transfer the request to one right different kind of application server. Now that 3,000 request, out of 3,000 requests, 1,000 will be handled by this server, another 1,000 by this server, and another 1,000 by this application server 3. Means now the application can easily handle 3,000 requests per minute. Clear? Clear or
Yep.
not?
Yes,
Clear.
sir.
Yeah.
Now let assume, right, in this case, right, let assume first, let us understand this scenario, right? So in this case, let assume here you have implemented in memory caching. Suppose, I'm talking about suppose you have implemented here in memory cache. And this in memory cache means it is going to store some, right, what I can say, country master, one key is there, country key, right? And it is storing that list of, what I can say, list of countries. Similarly, it is going to store some kind of another key that is going to be my right city master. So it is going to store list of cities. Let assume these are the data. Now, so in this case, in case of in-memory caching, so whenever the request comes, this data is stored inside the memory cache. So now, if I move my application to load balancer with in-memory caching, so data, right, the same data will be stored here or not? Yes or no?
Yes.
Again, the same
Yes.
set of data will be stored here or not? Again, the same
Yes.
set of data will be stored here or not?
Yes.
Why? Because each server is having its own memory. In memory means the data is going to be stored in the same server memory. Clear?
Yes.
Yes or no? Yes or no?
Yes. Makes sense. Yeah.
Yes.
Okay, so basically each server having its own memory. In memory means it is going to store in the web server memory only. So wherever your application server one is hosted, inside that memory it is going to create a country key, city key. Inside here again the same thing. Now assume that this country and city information what you stored here, right, in app server one, another request come and that another request update this country and city data. So now the same country and city data which is available in memory cache of app server 2 and in memory cache of app server 3, are they going to return the updated information?
No, sir.
That means there is some issue with the cache data or not. So this problem we can overcome by using the Redis cache. So now instead of a memory cache, so let assume we have used to distributed cache. Distributed cache means it is going to be in an external server. External server. So now, so this is distributed cache external server. Now with this change, so when the request come here, right, what exactly it is doing? It is storing the data in the distributed cache. Now, so when the request comes to application server 2, is it going to store the data again? Or it will fetch the data from your distributed server?
Fetch from the distributed.
So definitely when the request come to, so in this case, it is going to communicate with the distributed server and fetch the data. This distributed server, it is completely a different server altogether. Like your application server 1, 2, 3, there is another server that is going to be distributed server, cache server, external server, whatever you call, right? And this application server 1 will communicate with this server. Application server 2 will communicate with this server to get and set the data, and the same in the case of here. So if application server 1 store this data in the cache, when the request comes to application server 2, he can fetch the data from here. And same in the case of application server 3, he can also fetch the data from the cache server. Now, if any of the server update this information, that means the data is going to be updated in the distributed cache. That means once the, let assume this application server 2 update this country master and city master data and stored it in the external server. Then when the request comes to application server 1, he will communicate with the same distributed server means he will get the updated data. Am I right?
Yeah.
Right. So that is what I'm showing here. So in case of a distributed caching, right, when the client request will come, so it will be handled by my load balancer. So this load balancer, right, you can say my application is, I'm having 3 application server, application server 1, server 2, server 3. So you can give any number of, so it is not like that only 3, it can be any number, right? And when the request comes, so first of all, you can see it is going to check, right? It is going to check whether the data available in the database. I mean, when the first request come, it will check the distributed cache, whether the data available in the cache or not. So this distributed cache means it is a different server altogether. As the data is not available in the cache, so what exactly it is going to do? It will fetch the data from the database. So when the application server checks some data in the cache, If the data is not available in the cache, this is called cache miss. In the case of a cache miss, my application server will retrieve the data from my database. And once it retrieves the data from the database, then it will store the data in the distributed cache. Clear? So when the data is available in the cache, it is called a cache hit. If it is not available, then if it pastes the data from the database, this is called cache miss. So once it pastes the data from the distributed cache, then he can store the data in the cache. Then the next subsequent request, whether the subsequent request comes to application server 1, server 2, server 3, first of all, they will check the distributed cache. If the data is already available, this is called cache hit. In the case of cache hit, simply they will return the data from the cache server, and that data they will format and return to the client who initially made the request. Clear?
Yeah.
Yes, sir.
Yeah.
So let us proceed and see how we can implement using Redis. So Redis, basically the short form for a remote dictionary server, is an open source in-memory data store primarily used as a caching solution. So primarily used as a caching solution, but it can also be used as a database and a message broker. So that database message broker is not part of our right discussion. So completely ignore that database and message broker concept for now. Primarily, we are going to use Redis as our distributed caching solution. It is going to store the data in the form of a key value pair, and it can store the data in a different format: list, set, hash, sorted set, string, JSON. So every format, right, where you want to store the data, you can store. So the performance is going to be very high, right? Because it is going to retrieve the data from the RAM rather than the disk storage. It supports a different data structure, right? List sets. So rich data structure is also supported by Redis cache. So Redis is commonly used, right? In particularly in .NET Core, Redis is commonly used as a distributed caching solution, and it helps frequently store, right? It helps us to store the frequently accessed data in memory so that subsequent request can be solved quickly without hitting the database. Right? So let us proceed and see how we can implement Redis on our Windows 10 and 11. So guys, remember, Redis is primarily designed to support Linux and Mac operating system, but it is also possible to install Redis server on our Windows 10 or 11 machine. So let us proceed and see how we can install this. So first of all, you need to go to this GitHub, right, link, whatever I have provided here. So once you come to this part, right, then you will see there is a zip folder, Redis x64. So this is the zip folder which is going to contain the Redis server application, Redis CLI application. So that Redis server we need to set up the Redis on our Windows machine. So once you click on this file, then what will happen? It will download this zip folder, Redis x64 zip folder. So you have to unzip this one. So once you unzip, then you will get this code. Clear? Till now clear?
Yeah.
Right. So once you install this thing, right, then here you need to observe two things. One is Redis server, another one is Redis client, CLI. So this Redis server is the server which is going to handle the caching mechanism, caching functionality. And this Redis CLI, it is the client tool you can consider. Using this tool, we can test, right, whether Redis server is working fine or not. So first of all, what you need to do, you need to run this Redis server. So double click. So, and once you start, if you are getting this message, means your Redis server is now ready to accept connection. And by default, it will accept the connection on which port number? That is 6379. So this is the port number on which the Redis server is running. So now once the Redis server is running, then what I need to do? First of all, you need to download this one. Then you need to unzip with the downloaded folder. You will get this one. Here you need to observe two things. One is Redis server. One is Redis CLI. Redis server is the server which you need to start, which is going to provide the port number on which the Redis server is running. This port number, whatever you are seeing here, we can use this port number to send the data from our .NET Core application to the Redis server. And to test, right, whether the Redis server is working as expected or not, we need to run this Redis client, right? So once you run this, right, double click on this Redis CLI. So to test whether the Redis server is working fine or not, just send a message ping. So once you send ping, you should get a response called pong. So this will tell that Redis server is working fine. So if you send ping, you got pong, means Redis server is fine. Now to work with this Redis server, some basic command is provided. So you can use set command to store the data in the form of a key value pair. So this is going to my key and this is going to my value. To get the value associated with this key, I need to use this get command. And to delete this key from the cache, I need to use this delete command. So let me first show you this thing, whether it is working fine or not. So this is going to be set country India. So in this case, this is my command, which is going to set the key value in the Redis. So country is the key, India is the value. So now, once you copy once you provide this thing, please okay. So if you are getting okay, means the operation performed successfully. Now, to retrieve the value based on the key, so what you need to do, you need to use the get command. You need to provide the key, and once you click it, then you will see whatever the value associated with this key, that what I'm getting. And if you want to remove one key, then you have to use the del command and click this one. So integer one means what? So one key is deleted from the cache. So once the key is deleted, now if you try to access it, or in previous case, we got this value. Now this key doesn't exist. So if the key does not exist, and if you try to access, then you will get nil. Means no data is available. Clear?
Yeah.
Is that clear, guys?
Yeah.
Yes,
Yes,
Yes, sir.
Okay. So that's fine. Now what we need to do, we need to see how we can integrate Redis Cafe in our ASP.NET Core Web API application. So basically, I'm going to create a simple .NET Core Web API application. And in that application, I'm going to provide some kind of Red product information. And I'm going to show you how you can use Redis Cache to store the product details in the server. I mean the Redis server. So let me go ahead and create a project with the name Redis Caching Demo. So open Visual Studio. So create a new project. So create a new ASP.NET Core Web API project. Select a location where you want to create the project. Then click on the next button and click on the create button. So once you click on the create button, then it is going to create the project. Right? So the project is being created. So once the project is created, next what we need to do, we need to install some packages. So what are the packages we need to install? First of all, I'm going to communicate with the database, SQL Server database using Entity Framework Core. So Entity Framework Core related packages, which are specifically designed for SQL Server, that what we need to install. Secondly, we need to install the Redis Cache package. Oh, sorry. So let me go ahead and install this package. You can install these packages using package manager solution or using the PMC command. PMC means package manager console. So let me go ahead, open the PMC command, that is NuGet package manager and package manager console. And I generally prefer to use this PMC command. So install this package. So this will install the data provider for Entity Framework Core data provider for SQL Server database. So this package is going to be provide the support to communicate with the SQL Server database using Entity Framework Core. The second package, what I'm going to install, this tools package, it provide you support to generate and apply the migration so that your code base is always going to be synced with the database. So for that purpose, I'm installing the second package. And this third package, what Stack Exchange Redis, what I'm going to use, this will provide the support to implement, or you can say integrate, distributed Redis cache in our application. Clear, guys? What are the packages we have to install?
Yeah. Okay.
Okay, now what I need to do, as I'm going to communicate with the database using Entity Framework Core. So first of all, I need to define the model. So what I'm going to do, I'm going to create a folder called models in the project root directory. So this is going to my models folder. Inside this models folder, I'm going to create a product object, which is going to define the properties which are required for creating a product. So this product of entity, right, is also going to decide what is the table structure in the database. So let me go ahead. So you can see I'm creating this product entity with the ID, name, category, price, and the quantity. So these are the information which I want to store in the database. So next, what I need to do, I need to create the DP context. So let me go ahead and create a folder called data. So within this data folder, I'm going to create my DP context, which is responsible for communicating with the database using entity framework or code first approach. So this is my DP context. So within this DP context, what I need to do, I need to define the DB set property, as well as I need to provide some initial seed data for the testing purpose. So you can see this is my on model creating method, which I override. And here I'm creating a list of a product. So product with ID 1, 2, 3, 4, 5, 6, 7, 7 products I have added. And I have provided some dummy price name, whatever, some dummy data I have inserted. And then I'm calling this a hatch data method using this, and to that method, I'm providing this initial product. So this list of products I'm providing here. So this will insert data. And here I provide this product division property. Guys, give me 1 minute. So this is going to define the product rate table in the database. Clear, guys? So what we have done, we have initialized some initial domain data, and we have decided what should be the table name in the database. Clear?
Yeah, yeah.
Okay. So next, what I need to do, I need to provide the Redis cache configurations, as well as what I'm going to tell you. I'm going to define the connection string. So let me show you that connection string. The database name is going to be products DB, and this is what you already know. Now, so here you can see I have defined one section, Redis cache options. So whatever name you want to give, you can give. That configuration is nothing but your IP. I mean the Redis server, wherever your Redis server is running, that information you need to provide. Instance name, anything you need to provide. So this configuration, it is nothing but it is holding the IP address, or you can say IP address and the port number on which the Redis server is currently running. For example, this localhost means what? Localhost means the Redis server and the application both are running on the same server. I mean on the same machine. So in my case, it is on the same machine, right? And that means the localhost indicating that both Redis server as well as the application both are running on the same machine. But in your case, if whenever you are setting the Redis server dedicated in, I mean, whenever you are setting the Redis cache in a dedicated server, that server IP address you need to provide along with the port number on which on which port number the Redis cache is running. That what you need to provide. So in this case, localhost means it is running on the same machine where the application is running. Clear?
Oh, yes, sir.
Yeah.
Yes, clear.
So this instance name means, right, it is specifically used to avoid the collision. So what do you mean by, sir, avoiding the collision? For example, let assume I'm going to have different applications, right? My order API is there, right? My payment API is going to be there. Right? Some different applications are there, right? For example, some application one is there, some app one is there, some app two is going to be there. So different applications are there. So now, so this order API going to create some key. Some keys are going to be created here. Some keys are going to be created here. Some keys are going to be created here as well as here. So now it is possible that this order API going to create one key called some key one. Some key one. Let assume. And the same key can also be created by your payment API. So if it two different applications, and in my case, all this order API, payment API, some API one, some app two, right? Everyone, all these four applications, they are using the same Redis cache. All are using the same Redis cache. Now you just tell me if my order API is same with payment API or both are different.
Different, sir.
Guys, tell me both are
Different,
same or
different.
both are
They're
different.
different.
Yeah.
Different.
Both are different. That means here let assume you store some value, right? The ORD1, and here you have stored the value that is PAY1. Now what will happen? So here the request when it comes, then how these things are going to be handled? Now when you retrieve and if you are passing some key one, then how the Redis server is going to differentiate that I need to return pay one, and when the request is coming from order API, then I need to return right ORD one for this key. So how the Redis cache is going to handle this thing? So Redis cache is going to handle this thing based on this instance name. So whatever the name we specified for this property, so this instance name, right, for this property, whatever the value we specified, so that value it will take. And see, from your application, you pass this thing, some key one. But in Redis cache, right, let assume from Redis cache, it is going to create the key with this name. So whatever the instance name you specify, that will be prefixed with your key, and that is going to be the key in the server. Similarly, let assume instead of a Redis cache demo, you provide the name as a order API, right? So in the same way, here whatever your payment API, you provide the right instance name as a payment API. Now you can see from your order API you are passing some key one, from payment API you are also passing some key one. But in the Redis cache, it is storing that key with what name? Now, whatever the instance name you specified plus your key name. So, whatever the instance name you specify plus your key name. So, in this way, it can avoid the key collision. Means if a different application sending the same key to the same Redis server, it can handle them efficiently using this instance name. Clear?
Yes.
Anyone
Yes, sir.
having any question? Clear, guys?
Yes, sir. Clear.
Yes, sir.
So this settings is clear
Yes, sir.
now.
Sir, the port
Now,
number will be same for every Redis cache server.
see, by default, this is the port number. But again, whenever you are hosting this application, right? So this will take one default port number if it is available. Otherwise, you can give a, for example, if this port number is given to some different application, you can give a different. But ideally, this port number is always available. But please make sure, right? Whenever you are running your application, on which port number the cache server is running, that port number you need to provide. Clear?
Okay.
Right? Again, right, wherever you host, you need to, right, you do not need to think too much about this. So whichever the infra team, right, they're setting up this cache server, they will give this information, right? What is the IP address? What is the port number? On which port number, right, your Redis server is running? This information you will get, and you just need to update this configurations. Clear, guys?
Sir, in production, we need to mention the IP address with port number or just IP address.
So what you need to return mention. See, for example, right? How? Right? Because right, only using this, what I can say, port number, it cannot possible. For example, in your server, right? If multiple Redis cache server, multiple Redis cache is running, then on which Redis cache is going to right, handle this information, right? For example, you just tell me if you are having IIS server, do you think that within the IIS I can only host one application, or it is possible to right, host multiple applications?
Multiple applications.
So then how it is going to differentiate? So each application is going to have a different rate, what I can say, the port number or the local IP address, right? They are going to be different. So whatever the available port number, that what you need to provide, so that on that port number only, it's right, the application is going to be run. For example, whenever I'm running my application in the local, so each application having the same port number, or each one having a different port number, even in your local machine.
Different.
Port number.
So each application is going to have a unique port number. That what you have to specify. And otherwise, you will not identify right where to store the data. Clear?
Yeah.
Okay. So next, what I need to do, we need to configure the cache settings in our application. See, first of all, what I'm specifying, right? Please ignore the camel case naming convention. Whatever the property name, please use the same property name as it is in the case of a JSON serialization and a deserialization. Then what I'm doing here, I'm specifying that my application DB context is going to use SQL Server database, and the connection string it is going to read from the app settings.json file with the key name default connection. So this is nothing but your Redis cache configuration. So this is what we need to understand. So to use this add stack exchange Redis cache service, first of all, you need to install this package, which we have already installed, right? And to this services, we need to specify two information. One is what is the configuration. I mean, the right connection string you can consider how the application is going to communicate with the Redis server, that connection string. So that connection string is nothing but this local host and this value. The second one is the instance name, that what you can read from here, right? So that for reading this information, we are using builder.configuration, whatever the key, that what it is going to return the configuration value, that what we are reading, and here we are reading the instance name. So that is fine. So now additionally, what I'm doing here, I'm configuring one service, right? I connection multiplier. So what exactly this I connection multiplier service is going to provide? It is going to give me a direct communication with the Redis server. So for example, if I'm not going to use the I distributed cache, right? I distributed service interface, right? So basically, if I want to communicate with the Redis server directly, then for that purpose, I need to use this I connection multiplier. And while I'm registering this service, I also need to specify what is the connection string. So how to use this one, when to use this one, that what we will discuss right after some time. For now, right, if you are not for now, if you comment this thing, then also it is going to work, right? So let me comment this thing. Right? So what is the use of this? When I will use at that time, I will tell this thing. But for now, right, this is more than sufficient. So you just need to configure this add stack exchange Redis cache service. And to this service, you need to specify what is the configuration value and what is the instance name. Clear?
Yeah.
Right?
Yes.
So this I multiplier when to use at that time I will explain what is the use. So once this is done, next what I need to do, I need to generate my migration file. So how to generate the migration file? So you have to write migration image1. It is taking some time to build the project as it is building for the first time. Okay. Then we need to update the database by writing the update database command. So this will create the database and also the products table with the initial data. So now if you look at this, the products DB is going to be created, table is going to be created, and the table should have some initial, right, what I can say, testing data. So if you run the select query, then you will see these 7 products what we have provided in the hatch data method. These 7 products are being added to the database table. That's fine. So now what do we need to do? So once this is done, next what we need to understand, we need to understand how to use Redis cache in our ASP.NET Core application to set the data, to get the data, and to remove the data. For that purpose, what I need to do, say, for that purpose, what I need to do, I need to use I distributed cache service. So I distributed cache service is specifically designed for communicating with the distributed cache. Similar to the iMemory cache. iMemory cache is specifically used for memory cache. Similarly, I distributed cache means it is specifically designed to communicate with the external services. I mean external cache provider. So this I distributed cache provides some method like the get string async, set string async, and remove string async. So this method are going to perform the operation asynchronously. Asynchronously means it is not going to block your main thread application execution in the background thread, right? They are going to perform the operation. So these three methods you can use to set the data, get the data, and remove the data. Let us see how to use these three methods. So as you know, set string async means it is going to set a key with the associated value in the distributed cache. So how you can going to do this? For example, let assume I'm going to load, I'm going to store the list of products. I'm going to store the list of a product data in the memory, I mean in the distributed cache. How I can do this? First of all, what you need to do, you need to fetch the data from the database. Yes, I need to fetch the data. So context.products has no tracking and to list async. So I got the data. So once I got the data, then what is the second step? You need to serialize the data into JSON format. So yes, JSON serialize. I convert that data into a JSON string. So once I convert that data into a JSON string, then optional. So this creating this distributed cache entry option is optional. So using this optional object, right? If you need, you create. Otherwise, if you don't need, you can go with the default duration of 30 minutes. So in this case, what exactly I'm doing, I'm going with this cache option entity. And here I'm specifying that this cache data is going to be deleted from the cache with the sliding expression. So sliding expression means what? Now I'm setting this time to 5 minutes. So each time you access the data within the 5 minutes time period, that value is going to be reset. So sliding expression means each time you access that rate expire value, rate expire time is going to be reset. And then once you have the serialized data and once you create the cache entry option, then what you need to do, you need to store this data in the cache using a unique key with this cache option. How? By calling this set string async method. The key is going to be some cache key. For this key, whatever the value, that what a JSON value I'm providing, and I'm also specifying that cache option. So this is going to be sliding expressions. Clear?
Yeah,
And
clear.
I'm not going to explain, right, what is sliding expression, what is absolute expression. So these things we have already discussed. So the way it is working with the memory cache, it is going to work with the same approach only here, right? So the functionality it is going to be same. Any question from anyone related to the syntax, right, of how to use distributed Redis cache to store the data? Clear or not?
Clear.
Clear, sir.
Now, so how to retrieve the data? For retrieving the data, what we need to do? We need to use a get string async method. So to this get string async method, whatever the key you use to set the data, the same key you need to use to retrieve the data. So while you retrieve the data, so it is going to return you the string value, JSON string, and you need to check whether this JSON string is empty or not. If it is not empty, means available, then you can deserialize the data. If it is not available, that is going to be cache miss. In the case of a cache miss, you need to retrieve the data from the database. The actual implementation I will show you practical. For now, how to retrieve the data means you have to use a get string async method. Clear? And to this method, you need to pass the key name. And as this is a asynchronous method, so you have to use the await keyword. Clear, guys? Is that clear?
Yeah, clear.
Yes, sir.
Okay, now if you want to remove a key, then what you need to do, you need to use this remove key method. So remove async method, to this method, you need to specify the key. And once you specify if this key is available in the cache, then the associated value and this key is going to be deleted from the data, I mean from the Redis server. Now here one challenge. So what is the challenge? Sir, what will happen if this key is already available in the cache server and again I'm going to store some data? Let assume initially whenever you retrieve, 5 products are there, and those 5 products you store in the database. Some from some other places, again you are going to store the data using the same key, but this key is already exist in the cache server. Then what will happen? In that case, it is going to override the data. So whatever the latest data, that data is going to be override the older data. Clear? For example, first time 5 data, from other places you are going to store with the Data which is containing only 3 products means the value going to be updated with those 3 products. Clear?
Yeah, clear.
So this will happen in the 5 minutes, you said?
Not 5 minutes. So within the 5 minutes, right, that the duration is going to be reset. What I'm saying, so for example, here you created one key. See, after 5 minutes, definitely, right, that key is going to be deleted. Doesn't matter. So within the time period, so what I'm saying, if key is still valid in the cache, if this key is still valid in the cache, and if you are trying to store some other data, some different data with the same key means that updated data or whatever the latest data that going to be replace the old data.
But with warning or not?
Clear, guys?
Is it going to use warning? Hello?
Yes.
Yeah,
Simply forget, right? Forget all this thing. Simply every time you add this key, whatever the data you provided, that is the updated data. Always it is going to return. If the same key
okay.
exists with old data, that old data will be replaced with the new data. That is as simple
Okay.
as clear.
Yes, that makes sense. Yeah. Thank you.
Right? So now, so once you understand this thing, next what we need to do, we need to see how to implement that Redis cache with a typical RAID operation in our .NET Core application. So create a controller. So name this controller as a products controller, and then, all right, let me. Okay. Please observe. So now, so here you can see what I'm doing. So I'm configuring my application DB context. Definitely, this DB context is required. Why? Because to get the data from the database. And this cache is why? To store the data in the Redis server, external server. So both of these services I have initialized through the constructor. So now this is my get all products method. So here I have created one key. So always please remember to give some kind of a unique key. So this is my get all products key. And here this is my list of a product. So I created a variable, I created a key. So this variable is not right what I can say in this list. Okay, so let me do one thing. So to avoid runtime exception, let me initialize this with an empty object, right? So now what I'm doing here, first of all, when this method execution start, so what I'm doing, I'm trying to access this cache data. I mean, based on this key, I'm going to fetch the data from the Redis cache. So then what I'm checking here, I'm checking whether some data is available. If this key is exist in the Redis cache, then the associated data he will return. And if he returns some data, then definitely this is not going to be null. So data type is going to be string nullable type. If he returns some data, then that data is going to be stored here. Otherwise, if this key is not exist, then or this key data is expired. So in that case, it is going to return null. So if it returns nulls, then we will come to the else part. If it returns some data, right? Then I mean, if this data is not null or empty, then what we need to do, whatever the data cache data, that what we need to deserialize. So that what we need to deserialize here. So now, right, what you can see here, I'm using this not. I mean, if this is empty, if this is null or empty, then it is going to create one empty, right? What I can say, empty list of objects. So this is nothing but deserializing. Why? Because here I'm getting the JSON data, and that JSON data I need to convert to the actual object. So actual object in this case, list of products. Clear?
Yes.
Yes. Yes, sir.
Let assume the data is not available. Then it will come to the else part. See, if data is available, then this is cache hit. So if data is available, this is called as a cache. This is called cache hit. If data is not available, this is going to be your cache miss. So in the case of a cache miss, what we need to do, first of all, I need to fetch the data from the database. Then I'm checking if this object is not null, I mean some data is available. Then this object, first of all, I need to serialize into a JSON object. So once I serialize into JSON object, then I need to create an instance of a distributed cache entry option. specifying what is the duration rate, I mean, what is the expiration criteria and how long it is going to be valid. And then I'm storing this cache data with this cache option and using this cache key in the Redis cache server. And finally, whether the data is retrieved from the cache or it is retrieved from the database, that data I'm returning. So if it is retrieving from the cache, no issue. I'm simply deserializing and returning. But if it retrieved from the database, then I'm converting that data into JSON, storing that JSON object into the Redis cache before returning to the client. Clear?
Yes, sir.
Right. Now, so this is get product by category. So basically, based on the category, for example, if you look here, I'm having two category data. One is electronics, another one is groceries, another one is footwear, right? So different categories there. And based on the category, if you want to return the data, and for that purpose, this method is going to be used, and it is going to create a key, unique key based on the category. So products underscore category. So based on the category, what you provided, it will create a key. And again, the logic is going to be same. So what is the logic? First, we need to check in the cache whether the data is available. If available, convert that data into appropriate type and return. If not available, fetch the data from the database, store the data into the cache, and then return the data. Clear?
Yeah,
Clear? Or
yeah,
okay.
clear.
Now, this is my get product by ID. So in these two cases, it is returning what data? It is returning list of a product. So list of product means better to use this list of a product. So public async, right? Task of action result of list of a product. Clear? And the same thing I need to update here. Okay. Now, so in this case, the get product by ID means how many information it is going to return? A single product. So the return type should be action result of a product. Clear?
Yes.
Okay. So here, based on this ID, it is going to create a unique product key. So basically, for each product ID, it is going to create a new product. I mean, new cache key. The logic is going to be same. If the data is available, convert that data into a product. See, in this case, whenever I'm deserializing, I'm not using a list of products. I'm using only product. Why? Because in this case, I assume the data is going to be a single product only. And if it is a cache miss, then it is going to return the data from the database. And then if the data is found, that's fine. Otherwise, it will return not found error message. And if the data is found, converting that data into JSON and storing that data into the into the string method. Now, in this case, directly I'm specifying this thing as part of my third parameter. So in previous cases, we created this cache option object and passing that as a third parameter. And in this case, directly I'm creating that on a object right within the third parameter. So this is my update product, guys. Remember, so in this case, whenever I'm going to update any product information, for example, let assume, so this method, I'm passing product ID 1. So basically, when I pass the product ID 1, so it is going to create one key with the name product underscore 1. And that product underscore 1, and after retrieving the data from the database, it is going to store in the Redis server. Clear or no? Yes or no?
Yes.
Yes.
So now, if that same product information is going to be updated, I mean, so for example, whatever the name, category, price, quantity was there, so this information is updated. Some different information, I mean that information is updated. So once the information is updated, then what we need to do? Do I need to remove this key from the cache? Yes or no?
Go.
Yes or no?
No, sir.
Why no?
Because
It
See,
will
if the
overwrite.
data is updated, see, currently the name is Apple iPhone 14, the price is 999, quantity is 50. And this price is changed to 500 or 1500, that name is updated. So do you want to provide the client the updated information, or do you want to return the old information?
Updated
Updated information.
Updated.
So updated information, how you will return without deleting this cache from the, I mean this key from the cache. So because when the client will make a request to the server, it will check this key and whatever the data available in the cache, that old data it will return or it will go to the server and return the, I mean paste the original data. So
Hold on.
basically, whenever I'm going to update the information, so this cache key I need to delete. So let us see how we can do this. See, in this case, what I'm doing here. So this is going to update one product information. And once the product information is updated, again, what it is doing, right? You can see it is storing that same key again. Getting my point? So instead of this thing, right, what you can do is, right? So in this case, what logic I have implemented? In this case, I have implemented the logic is called pre-initialization, I mean storing the caching data. So if you don't want to use this thing, then what you can do is create the cache key. So once the cache key is created, then what you need to do? You need to use the remove method. What method you need to use? You need to use the remove async method. So this will remove the key from the cache. Clear? Clear? But that functionality I'm not showing here. So what I'm doing here, please observe. Now, as I mentioned you earlier, right? As I mentioned you earlier, now if this key is storing some data in the cache, and if again I'm using the same key to store some updated information, so currently it is going to hold the updated data. So this updated information will return to the client or the old data. I mean, whenever I'm using the same key with new data, then that key is going to be updated with this data in the server, cache server or not.
Yes.
That's what we need to do, right? So, okay, let me do one more thing, right? So whatever the existing product, so let me going to update the product price. So product price, existing product dot name, this is name, and existing product dot quantity equals to this thing. So this is the things that what we need to update, right? And then we need to call the sub changes method. Clear, guys? This segment is clear?
Yes.
Yep.
Okay. Now this is my delete method. So once we delete a particular product, I mean once we remove that product, then what we need to do? We also need to make sure that product representing the key, right? The classic key representing that particular product, we also need to remove. For that purpose, what we need to do? We need to use this remove async method. Clear?
Yeah, great.
Okay. So whatever the changes we have done, let me take and update here. So that's it. We have done our implementation. Let us proceed and test the functionality and see whether it is working fine or not. See guys, with the caching enabled, right, the first request is going to be take more time. So this is my application. Suppose I want to retrieve all the products. I need to make a request to this endpoint. See, first request it is taking. So how much time it take? It took around 1.19 seconds. Now, but from the second request onward, you will get the response in very less period of time. You can see it is coming within 5 milliseconds, 4 milliseconds, 6 milliseconds, right? So that the time is drastically improve or not with Redis cache. Why the first request took more time? Because at that time it will fetch the data from the database server. Fetching the first of all, it is making a request to the Redis cache to check whether the key is available or not. If the key is not available, again it is making a request to the database server, fetching the data from the database server. Then again it is storing that data into the cache server and finally returning. So this additional operation, that is fetching the data from the database server, storing the data into the data Redis cache, this is going to be reduced, right, from the second request onward. That is the reason why the second request is going to give you better performance. Clear?
Yes.
Right? Similarly, if you check this thing, right, product by ID, right, for each request, it is going to generate one ID. So, right, now you can see immediately I'm getting the response. Similarly, two means, so I'm getting the response. So, with the caching enabled, right, your application is going to be definitely going to give you better performance. Clear?
Yes.
Yes or no? Anyone having
Yeah.
any question related to how to implement this functionality till now? Okay. Now what we are going to do is, see guys, remember, implementing this caching service is important, but also we need to provide some kind of a mechanism for the admin to check and validate the data. For example, right? For example, one application is not working. So one application is not working. The user of that application, let assume mobile app team or Android team, iOS team or web team, they verify and they are ready to give you the information that we are not getting the updated value. I mean, some data is missing. So what you need to do? Then you need to check whether the data, whatever I'm storing in the cache, right? I mean, valid or not. For example, some of the clients saying that our application getting the value, but it is taking more time. So you need to check whether the data is right, whatever data I'm returning, whether the data is stored in the cache or not. If it is not stored in the cache, means some issue is there. You need to figure out why it is not stored. If some old value is there in the cache, you need to find a mechanism to delete those old information so that the I mean, delete those old data from the cache so that the updated information will be fetched from the server. I mean, from your database server. So for that functionality, what we need to do, we need to implement that cache management for our application. So basically, what I'm going to do is now, what I'm going to do is I'm going to retrieve all the cache keys and their associated values. So basically, from the cache server, whatever all keys are stored, and for each key, what values are stored, that information I need to retrieve. Also, I need to provide one endpoint which is going to return a particular cache object based on its key. So based on the cache key, what is the corresponding value? That what we need to return. Similarly, we need to provide one endpoint which is going to which is going to delete all the cache entries from the cache server. For example, your application reset, your application there is a major update, the cache right. I mean, most of the cache data stored in the cache is invalid. So something happening, and you want to delete all the cache entries. So that endpoint we need to provide, and obviously we need to provide an endpoint which is going to delete a particular cache entry based by its key. So let us proceed and understand how we can implement this functionality. So here guys, whatever all these endpoints are, is that clear? Retrieve all cache keys and values. Then we are going to retrieve a particular cache entry by its key. How to delete all cache entries and how to delete a particular cache entry by its key. Clear?
Clear.
Okay, so let us proceed and see how we can implement this thing. So basically within my controllers folder, I'm going to create one another controller. And guys, remember this controller accessibility should be restricted. It should not be accessed by anyone, right? It should be local to your machine, local to your admin team. Outside your network, right? They should not access this because this is very sensitive and very critical. So what I'm going to do is I'm going to create my controller. And guys, now, so to retrieve this information, whatever all cache keys are there, removing all the cache entries, right? So for that purpose, I need to communicate directly with the cache server. And for communicating with the cache server directly to get all the cache keys, to remove all the cache keys, right? For that functionality, this I distributed cache, they doesn't provide any method. So this distributed cache, they provide a method to remove a particular key, to get a particular key value, and to set a particular key value. This distributed cache, they doesn't provide any mechanism to retrieve all the keys. They doesn't provide any mechanism to remove all the keys. So for that purpose, what I need to do, I need to communicate directly. I need to communicate directly with the cache server. For communicating directly with the cache server, what I'm going to do, I'm going to use this I connection multiplier. So this I connection multiplier, it will make a connection from my application to the cache server. And that connection, right, I can directly use to get all the cache keys. I can use to remove all the cache keys. Getting a particular cache key, right, cache entry by key, removing a particular cache entry by key. So that is possible. That is possible using this I distributed cache. They have provided that remove method. They have provided that get method. But retrieving all the cache entries, removing all the cache entries is not provided by this I distributed cache. And for that purpose, I need to use I connection multiplier service. And to this multiplier service, how it will communicate, I mean, to which Redis cache server it will communicate, that settings we need to provide here. I mean, that connection string we need to provide here. So once this is provided, next what you can see, I'm using this distributed cache. When this will come into the picture, when I'm going to perform the individual operation. Individual operation means getting the entry information by key, removing a single entity, a single entry. So this connection multiplier, it is basically used. So this connection multiplier is basically used to communicate directly with the Redis server, and this configuration is basically used to read the Redis cache option settings from my app settings.json file. So these are the three services that what we need to inject. So now what is the use of this iConnection multiplier? So this will communicate directly with the Redis server. And this is through our distributed cache, whatever the method, this distributed cache, this method is not belongs to what I can say, your Redis cache. This is belongs to write your one package. One means this is related to .NET Core. So this method you can use whenever you are integrating any kind of a distributed server. I mean, if you are communicating with the Redis cache, Memcache, Ncache, whatever distributed caching, this is going to be the right method. I mean, this service instance you need to use. But now, specific to Redis cache means you have to use this I connection multiplier. Clear?
Yes, sir. So don't we need any credentials to connect to the Redis server?
See, that security you need to implement. That security, that credential, if you want, you can provide. That is advanced level settings you need to set. Right? You need to provide the what I can say. That user ID and password. The way you are communicating, right? The way you are communicating with the database using SQL Server. That is what you need to use. So now what I'm going to do is, right, I'm going to, first of all, I'm communicating with the Redis server. So I'm getting the server instance. And then using this server instance, Redis server instance, I'm calling this keys method and I'm converting that to an array. So this will return me all the, what I can say, key. But in this case, that key, whatever it return, that name is going to be something like this. So whatever the key we stored, that key name is going to be appended with this ready instance name what we provided. That means if I'm having this key, for example, if I'm creating this one, get all products, so then the actual key that what going to store in the Redis server is this thing. So Redis caching demo get all products. So that is how it is going to store in the Redis caching. So basically, and that key is the collection what it is going to return me. So now what do we need to do? We need to remove that name. I mean that prefix part we need to remove because that is what we do not want to show in the UI. So in the UI, we only need to show the key what we used in our application. So for that purpose, what I'm doing here, please observe. Now I'm creating one cache entries. So this cache entries is going to store the data in the form of a key value pair. So whatever the key we store and that corresponding value, that what we need to store. So once we have this list of keys, I can loop through each key. So each time I loop through, I will get that particular key. So that key, what I'm getting from that key, I'm going to replace, I'm going to remove this value what I provided. Why? Because this is not required when I'm going to fetch the data from the server. For fetching the data from the Redis cache server, this instance name is not required. But in this case, this server that keys what I'm using, it is retrieving me, right? It is returning me all the keys, right, with the instance name. So first what I need to do, so once I get the key with the instance name, I need to replace that instance name with one empty string so that that key what I'm going to get, that is going to be without a prefix. So once it is without a prefix, then you know how to get the data. So for that purpose, you need to use this get string async method. Pass that key, you will get the value. Once you get the value, then what you need to do, you need to create an instance, right? What instance? You need to create an instance of this key value pair. And that what I'm creating here, key value pair, what is the key and what is the value. If this value is not available, then store none. Clear? So this method what I have created here, it is going to retrieve all the keys along with its associated values. Clear or not?
Yes, sir.
Yes.
So this is get the cache entry by key. So based on the key, if you want to retrieve this value, so nothing special, you can use this distributed cache get string async method, which we have already discussed. So get clear all cache entries, right? For example, if you want to clear all the cache entries, then what you need to do again, so to get all the cache entries, you need to look through all the cache keys. Again, get the instance name, remove the instance name from the key, and call this remove method. So that's it, right? And then, right, I don't think, right, there is method to remove all the keys. So no, there is no such method which is available to remove all the keys. So basically, once you retrieve all the keys one by one, you need to remove. And this is going to be delete a particular key. Clear?
Yes.
Right now, let me run the application and see whether it is working fine or not. And guys, one thing you have to make sure, right? Whenever you are using your Redis server should be up and running. So now what I'm doing here, I'm fetching all the data. See, whatever the data, my application is restart, but this data what I'm getting, so this is right, returning me all the cache information now. So I'm going to invoke this method. So one key is there and that associated value I'm getting. Yes. Now I'm going to create a few more keys. So key with ID 1, key with ID 2. So two more keys I have created, and let's see whether these two new keys I'm getting or not. So for this purpose, so I'm calling this Redis cache all method. See, one key with product ID 2, another key with product ID 1, another key with get all product. So all these things are available.
Yes.
Now I want to delete a particular key, or for example, let me access this product ID 2 value. So for this purpose, what you need to do, you need to pass this key and see what is the associated value. This is the key and the associated value is this one. Now you want to delete this particular key. So pass this key and call this one. So once you see, you are getting this message, cache entry product ID clear. So once this is cleared, again, if you try, you should get none. Right? I mean that cache entry not found. So that error message I'm getting. So now what I'm going to do, I'm going to remove all the cache entry. See now with this is deleted. Now if you try, then you will see that cache red key is not no longer available. So here you can see product ID 1 is there, get all products is there. Now I'm going to clear all the keys. So once I clear all the keys, now if you try to access this method, right, then you will see an red empty object, means there is no more keys. Now once this data is deleted and if you try to access this information, then you will see it is going to get the data from the database. So let me give a breakpoint here. So this is my breakpoint. So now you can see that the key is there. So first of all, it will check in the cache. In the cache, the data is not available. Fetching the data from the database, and then it is serializing that data into JSON, setting the cache rate options, and storing the data in the cache and returning the data to the client. Clear? Clear or
Clear.
so this is how the Redis cache is working. Now, if someone asks you when to use Redis cache, Yes, please. Anyone having any question? Anyone having any question? Clear, guys?
Yes.
Right. Next, what I'm going to show you when to, if someone asks you when to use Redis cache or what are the benefit, high speed data access. The data is going to be stored in memory in the Redis server, so performance is going to be very fast. Scalability and load balancing means right, if your application storing the data, right? I mean, if you are doing with the load balancing environment, multiple applications, if you want to centralize the cache server, you can go with the Redis cache. Reduce the database load as it is a caching mechanism. Definitely, it is going to reduce the load on the database. Fault tolerance means what? If you are, which on mute, right? For example, if your right, if one of the application server goes down, not an issue because the cache data is going to be stored in a different, what I can say, server. Flexible caching option, you can go with absolute expiration, sliding expiration, right? So that is also possible and improved performance in high traffic scenarios. Definitely, right? As you are returning the data right in a very faster manner, means I mean, right? It is going to give you better performance. So these are the different things that what you need to remember. So this is all about your caching rate distributed caching. As from Monday, we are going to start ADO.NET. Clear?
About
Yes,
repository
sir.
pattern, you said? You forgot, Prayana?
Sorry,
Repository pattern, you said?
not repository. I'm talking about ADO.NET.
Oh, okay.
Repository we discuss. Don't worry, right? If something is there in the syllabus, until and unless all the concepts are not completed, I'm not going to stop the session. So whatever I have provided in the syllabus, every concept in depth, I'm going to explain. So next,
Okay,
what
thank
I'm
you.
going to start is because we have discussed so many examples, so many applications using entity framework core, and people are aware, right? Many people, right? Even many nowadays, many people they prefer to use ADO.NET over entity framework core. So, but those people generally, if you ask me, my personal opinion, I generally prefer to use entity framework core. But as ADO.NET is one of the data access technologies available, we are also going to discuss ADO.NET in depth. And first of all, I'm going to discuss ADO.NET core concept or basic concept using a console application. Similarly, the way we have explained the entity framework core basic concept using a console application, same approach I'm going to follow. I'm going to discuss the core concept or the basic concept using a console application. And then, right, once the basic concept are completed,